Let's graph another piecewise function. This one will be a little bit more interesting. It actually has two boundaries in it rather than just one. So let's first sketch those boundary lines. We see that our first boundary is going to be at -2, and our second boundary will be at +2. And we have three pieces to this function. So I'm going to go ahead and sketch in the lines that define these boundaries. Again, this is optional, but you may find it helpful. Now I'll find 2 points for each of these, since each of these does constitute a line. We have a constant function up top, but it's going to form a line this time. So I'll find 2 points for each one. Now on the first line, for the constant function 2, I'm going to find the value of x equals -2. Now we're not defined for this piece of the function at that point, but it is a boundary. So where x equals -2, the constant function equals 2, and we'll find one more point. We'll say x equals -5, and at -5, this function also equals 2. So our 2 points will be at -2, 5, sorry, -2, 2, and -5, 2. At -2, 2, again, the function is not defined. That is a boundary, so we use an open circle to define that. And at -2, 5, that's not a boundary of the function, so I'm just going to put a little dot there to guide my my line. And I'm going to freehand the line in here, so it may not be perfectly straight. But there's the first piece of our function. Now for, let's see, we'll change colors here, and we'll evaluate 2 points for x plus 1, the piece in the middle. Both of the boundaries, you see, are included in this, so they'll get solid dots. And these are the 2 points that I'm going to evaluate, -2 and +2. X equals -2, x equals 2, and we'll just plug those into the function. Whoops. -2 plus 1 equals -1, and 2 plus 1 equals 3. So my 2 points are -2, -1, and 2, 3. I'll plot both of those with a solid dot. -2, -1, 2, 3, and I'll connect them with a solid line. Then I'll evaluate a couple of points for the last piece. Let's see, we'll do this in green. 2x, and again, I'll define, or I'll evaluate at the boundary where x equals 2, even though it's not part of this piece of the function. 2 times 2 equals 4, so we have a point at 2, 4. And we'll just pick another point, x equals 4. I don't want them too close together, but I don't want to pick points so far apart that they might be off the grid. They're harder to plot. 2 times 4 equals 8. So another point at 4, 8. And we'll just plot, let's see, we'll plot an open circle for 2, 4. And we'll plot just a little tick mark at 4, 8. 4, 8, there we go. And we'll sketch in a line connecting those two dots. And there's our second piecewise function.